Venus and the Earth?
Oh, that's a good question too.
That's a good question.
Okay, can we read that? Okay. Should we make it a little bigger?
I think that's good.
Okay. So here's a question. How far will a 180 grain bullet drop at 500 yards, assuming a muzzle velocity of 3,000 feet per second? So let me first write this as 457.2, and that is meters per second.
Jaden,
Okay.
you got all pixely. Oh, there you go. You're back to normal. Phew.
So that was yards. Oh, sorry. I don't need a second, sir. My bad. That's the distance, okay, in meters. 457.2. And then the 3,000 feet per second, that's where I'll need the meters per second. Uh, and Kip, while I'm writing this down, will you explain why we want to use meters instead of yards and feet?
Because Americans are dumb and we should be using a unit system that makes more sense. That's pretty much, I mean, we could use yards and feet, but most scientists out there will use the standard units, is what they're essentially called, just because they're common throughout, the entire world. They make life easier, and most constants are calculated in SI units, and so that's normally what we use.
Okay. So
Um,
there's the two conversions. Do we want to show how we got that, or do we want to just leave it as that and answer the
Dude,
question?
nowadays you got Google. That's, I think, good enough. Most people will probably just Google it. That's what I do. So,
500 yards to meters, right? That's all you have to Google, and you'll
actually,
get that
I
answer.
use Ecosia. I don't know if you've heard of Ecosia, Jaden, but Ecosia is a search engine that plants trees for your searches that you do. So if you want to save the planet, use Ecosia.
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 This sounds like we're sponsored.
Yeah, for our 5 current viewers, they're all switching to Ecosia right now.
Yes. And then if you just barely joined the stream, if you have any questions, let us know in the chat. We will try and stay on top of that.
Yeah, or send us an
But right
email.
now we are currently answering this question here. So, Kip, this seems to me like a projectile motion problem. What do you think?
Yes, I think it does. It sounds very much
Okay.
like a projectile motion problem. Um, so in a classic projectile motion problem, you got two options. You got your y, right? And you've got
Okay.
your x component, all right? So your y component is going to be your vertical, right? How high something is going to be. And your x
Okay.
component is going to be um, how, I guess, how far, or I mean, it's your horizontal component. So you got your vertical and your horizontal component. Okay. Um,
Okay.
and so there's a kinematics equation that me and you derived a while back. Um, and it's this equation right here. My thing, right? We have 1/2, or no, sorry. Hold on here. We've got VIT plus 1/2 AT squared. And then we've got the same thing here. So this is VIY, and this is AY, and this is VIX. x t plus 1/2 a x t squared. So what these equations both mean is this is the displacement. Oh, we need a picture. We're going to ask for a picture.
A
So
picture of the problem, like us sketch it out real quick, or what?
yeah, I think so.
Is that?
So I'm look, we got this guy and he's got a gun. Shing, shing. Oh, dude, my gun is good here. It's way bigger than he is. Dude, I'm getting a blunderbuss. I don't know what this is.
Okay.
Okay,
Sweet.
there's our bullet coming out. Thank you for that, Kelsey. It's actually going to be very important to have a picture later on.
And we want to see, we'll call this 457.2 meters. And we want to figure out how
far the
how
bullet's
much
going to
it
drop.
drops.
Okay.
Like it's going to go, whee! Eventually it's going to hit the
ground.
Because
so
gravity.
Jaden, we have to debate something here, which is, I think to start, we're going to start with this. But if you notice, this is going to make the flat earthers really happy because in this problem, we're assuming the Earth is flat. So depending on how complicated we want to get, we may have to add in something else, which may make it a little more difficult. But we might be able to use a little bit of calculus or something along the way. So we'll see how difficult and complicated we want to make things. Again, all trying to make those flat earthers, not happy. Okay. So the first thing, Jaden, that we need to do is we need to figure out what's happening, like I said, in the y direction and the x direction, right? We've got these two equations, and so let's first by starting at the y direction, okay? So when this bullet isn't getting shot at an angle, we're assuming it's being shot directly horizontal, right? So we don't, so our VIY is equal to 0, okay?
Okay, so you're saying we have a 0 velocity in our up or down direction. It's not moving up or down at all. We're just assuming straight out of the muzzle.
Right. So at start, straight out of the muzzle, it's just holding steady, okay? And so its initial y velocity is 0.
So that means we don't need this.
Yes. Exactly. We don't need that. That goes away. And for you people that may not understand why, because 0 times anything is always going to be 0. Okay? So the velocity times time is going to be 0. Sorry. I got a message asking when we were going to be solving this problem. Okay. So.
Wait, from the person that asked this question?
Yeah.
Oh. Did you say right now?
Yeah, I said right now. Okay, we'll keep going and figure it out from there. Okay. So all right, so then from there what happens? So what else do we have? So looking at this equation, we have a 1/2, that's a constant, right? That's not going to change no matter what's going on. And then we have acceleration. So let's figure out what that is. Is there an acceleration acting on this object? Well, for our sake, we certainly hope so.
Yes.
Because if there wasn't, it's not going to drop, right? And this question is specifically asking for the dropping. So there is a force that's acting straight down, right? And this is the force of gravity, Fg, not, that looks like a K, Fg. Okay. And if we remember, our force is equal to ma, right? And so our
Right.
acceleration is just going to simply be the acceleration due to gravity. So our ay is going to equal negative, because it's pointing down, 9.8 meters per second, okay? And this
Right.
per second squared. And this is something that is a constant, like I was talking about. You just look up, or if you've done these enough, you know what that is. This is
Right.
the acceleration due to gravity at the Earth's surface. Remember, we talked last week about how that changes the further away we get from the Earth. But at the Earth's surface, this is what it is, and we're close enough to the Earth's surface that we don't have to worry about anything, and we just call it this. All right?
Right.
Okay. So, and then we have a t squared, and the t is our independent variable, and so we just leave that alone for now. So our
Right.
new y equation is going to be y equals 1/2 a negative, because we have that negative, right? 9.8 t squared. Jaden, do you want to take a turn on the x side?
Yeah, we can take a turn on the x side. So we know the displacement we want, right? So we know our x value right away because we have the 500 yards or the 457.2 meters. Okay. So that's how far we're going to go. We know our initial velocity because we are assuming a muzzle velocity of 3,000 feet per second, and that is 914.4 meters per second. We do not know our time though, right? That's what we need to solve in this part of the equation. And then we have the plus 1/2 ax. Kip, are we going to keep it simple and ignore air resistance, or are we going to throw in an acceleration that will slow it down in the x direction?
I think for this problem, we're going to ignore air resistance. Bullets
Okay,
don't have a lot of air resistance.
that is
Um,
true.
and this equation doesn't exactly hold up necessarily if we are using,
Yeah.
because air resistance actually changes with velocity. Um, and so this equation, when we take the integral, it will actually be different. There will be some other factors
Yeah.
involved. So we can't just simply say that this equation would work. Um,
Yeah. For physics 1 students, our acceleration here will be 0. Right? So that means we don't even need this part of the equation. Boop. Okay. So
and now,
we
Jaden,
have
we've seen that equation a lot of times before, right? That first part of the equation.
right. That's kind of like when we did a real simple distance equals rate times time. A lot of people have heard of that. Maybe you haven't, but that's something to just give yourself a real nice estimate of how long it's going to take you to go somewhere if you're driving on a freeway,
Right.
right?
So there's nothing slowing us down, right? We're gonna assume that this
Right.
bullet is in a vacuum.
Right. Uh, so then we have our x equation, which will be 457.2. That was a big 2, equals our velocity 914.4, and that is being multiplied by our time. Okay, so that is what we are going to want to solve for, and that will be able to give us our final answer, which will be our y.
Yeah, exactly. Um, So really quick for those that are new to projectile motion problems, one of the most important things is to figure out time, right? Time is kind of this value that connects the x and the y together.
Yeah.
The x and y are related to each other through time. Um, and so that's why it's important, and that's why Jaden automatically knew to solve for time. It also helps that it's the only value that we can actually solve for right now. Um, but if we can figure out how long it took it to travel a certain amount of time, then from there it becomes a lot easier to figure out um, how far it dropped, right?
Right.
So, Jaden, do we know what t is going to equal?
Let me get a fancy calculator out real
572
quick.
divided by 914.4 equals.
Okay, that equals just 0.500.
5 point what? Or what? 0.5.
0.5. You can just leave it at 0.5.
Okay.
And
And
that is,
yeah,
what
Jaden,
is our unit, Skip?
well, it's time, so I'm gonna say seconds.
Okay.
Okay. Alrighty. Now, if we create a new page here, um, and if you
New
remember
page.
from the page before, we had y equals 1/2, a negative 1/2, 9.8 t squared. So our t was 0.5, so we have a 1/2, negative 1/2. This is equal to negative 1/2, 9.8, 0.5 squared. And then from there, this is the same as 1/2, and so we can square 1/2 to get a 1/4. So we have 1/4, so we have a negative 1/8.
Um,
Yes, Jaden, are you okay over there?
okay. So, oh, I'm on the wrong page.
Could you not hear me there for a minute? Or can you not hear me?
For some reason, you got real quiet, Kip.
Can you hear me
I
now?
don't know if that's on the stream or not.
Can you hear me now, or am I still really quiet?
Can you still hear me?
Yeah, I hear you fine. And on the stream, they should be
Okay.
hearing me fine. Can you hear me fine now?
Uh, Sorry, I might just have trouble with my audio. Keep explaining it. Yeah, we got confirmation from Kelsey. He says, no, he is good on the stream. You're both good. So just keep explaining it. I'm just gonna be an expert at reading lips, okay?
Okay. Can you hear me still, or is it quiet?
Yeah, I can barely hear you, but I'm good.
Jaden, did you turn down your volume?
Try talking.
Can you hear me?
Let me see one extra thing. Just keep going. I'll
Okay,
figure it
you
out.
keep going. Alright, so now we need to use a calculator. And we go ahead and we do this, and we do 9.8 divided by 8 equals a negative 1.225.
Okay, and that is the same answer I got. And I think I can hear you better now, so we're
Okay,
good.
that's good. So, and Jaden, what's the units for that?
Uh, that would be meters.
That's meters. So, why? So that means that for this bullet to travel 500 yards, or 400 and something
Pew, pew, pew.
meters, it's going to drop 1.25 meters. Now, the average height of an adult male is probably about 2 meters. And so from your shoulders down, you're probably only, you're probably at 1.75 meters. So this thing's going to be barely off the ground. It's going to be about a half meter off the ground
Ew.
by the time it reaches 500 yards.
There we go.
And I think that we're just going to say that the Earth is flat because it's such a big object and we're going such a small distance that the curvature really isn't going to affect it that much.
Yeah,
Agreed?
I agree. If you are a sniper, you might disagree.
It's the difference between shooting them in the foot or in the stomach.
Yeah. But yeah, that's a good estimate of how much it's going to drop. Obviously,